Good morning, good afternoon, or good evening, depending upon where you live around the world. I'm extending my explanation of the accurately located holes on the hubs and the plates, and we'd had a bit of an overview, a second part to what I was talking about, and this one is really part 3, you could say. But this was to show the process and the jig that we're talking about, which is very, very simple, because we don't want to go down a path where we have to create an overly complex, unnecessary, and in the end less effective item, jig, whatever you, or tool, whatever you want to call it. I mentioned that if we have our hub, we can place in the center of it with a solid piece of like custom wood or plywood, and with the hole actually placed through the center, probably at the time of creation of the wee disc, you could put a rod through the center and then have pasted on from a print from your home office or your home printer a diagram of the angles that are the positions for the holes on the strut, for the hub where the struts go. This was the item I took. I simply went over to my other model, and if I just unhide everything or try and bring up the surfaces, here we saw the inclined angles, but below it are the angles taken from the struts, but in a flat plane relative to the center axis. And what I've done here, just for the exercise, these are the angles I'm interested in, and these were the ones taken from the inclined surfaces. Not a lot of difference, only the 2 degrees or so there, but it becomes more and more important as we start to develop our dome. So if I bring up the other drawing, this is it here. I shrunk it down and sized it so that it was able to fit on the disc. This then can be placed into the jig, and with this in mind, we can, once we've got it the drill centered on the top of the hub, and you can do that through just moving this backwards and forwards until the tip of the drill just scrapes the surface, and that's going to be pretty darn accurate. Then we can rotate our hub, which has the angles pasted on it, so the line comes down to our block, which is exactly center to the central axis of the hub combination. We can make our drill press, create the hole at that point, touching nothing other than, and this can be locked off. This was the way that Brian Proctor showed how he did it for his wheels, for his models. He had 2 rods coming through which had wing nuts on it, which clamped this in position, which is a jolly good idea. I'm just simply using one here in my mind. That's what we'll do to clamp the hub from rotation. And then of course, very simply, we come in, loosen it off, rotate everything around until it then gets to the next point, which I can't have grabbed everything. So we rotate that line till it comes round, and we drill again. Now the beauty of this, which I really like, is that there's no marks on the face of this. It's just not required, and the only thing that needs to be accurate is this surface here has to be dead center with your center line, so that when you rotate it around, the lines can register on this edge. That's it. Tighten it up, the nut up, drill, rotate it around again, drill again, drill, and at the end of it, you'll have all of your holes in as close as possible the exact accurate location. So I'll get rid of this. I don't need these. These were just this was showing the custom wood hub that you'd have, one on either end and mounted in your blocks. It's up to you how to do that. I'm just saying this is what I'd be doing, because obviously it won't be exactly the same for each person. The use of a smartphone with the protractor on it is also a good idea, where you could set this up. This would have to be a little bit higher so your phone could rotate, but you can actually mount the phone to possibly a bracket at the back or the front, depending on how, probably the front, and then as you rotate it and it registers the correct measurement, lock it off, make your drill form the hole, and again same thing, just keep on dialing it around until you've got all the measurements, because you're going to get a physical reading as well. And of course apparently you can, I haven't downloaded it yet for some reason, it won't download on my phone. I did my mate's this morning but not mine. You can zero it, dial up the precise angle, which are these ones, and keep on doing it until you get the desired result. Now I made comment about the only issue here is that we need to get this distance accurate. Well, once you've got the starting point, which hopefully you've figured out somehow, say it's 20 millimeters, well the next one might be 23 millimeters. Having a second plate underneath here that allows this to slide backwards and forwards, you can achieve that by either feeler gauges, or a wee bit more, the way I'd do it was have two threads, or maybe one, and if you know the pitch of the thread, and many of the diameters, the metric diameters, they'll come in fractions of a millimeter or a combination, and by turning the thread round a certain amount will push the block back along with your hub. Very, very straightforward. As I said, I've actually made them for stop blocks for my work table and my drop saw, etc. For a very similar reason. I needed to be able to accurately and repeatedly position the block, turn the bolt, and it will give me exact positions for my my drop saw, my miter saw. So I envisions doing the exactly same thing, and that way you can get not only the radial accuracy for your holes, but also the lineal accuracy for the holes. You'd probably, if this was set up, you'd because they all come in pairs, you'd probably choose to drill. I'll just hide this. You probably would want to drill the paired holes, say for 50.7 and 50. So these ones would be drilled. You'd drill two of those and move it around, because there's another pair. You drill the paired 49.5, 49.5, 0.5, yes, that's what it is. And once you've got those two, it's just a matter of doing the last ones. That means that you don't have to keep on moving this backwards and forwards. And for a 6 strut hub, means only moving it 3 times. So sounds pretty darn good to me. the rotational, if you're going to use the plate here, I can see how a similar jig just rotated around in the 90 degrees would work. So whether you're using this type or this type, both approaches work for it. So yeah, jolly good. I'll have to make a model, won't I? Oh dear. Righty ho, that's it. Just following up, just to show what I was contemplating, and yeah, we can go forward with that. Rightio, see you later. Bye.